Welcome. This is the Pan-Cancer's Synthetic Lethality Explorer tool. You will find that we have pushed it live to tumor.mocomakers.com. However, it can also be run locally. We are introducing a research concept called synthetic lethality, and it is where you have a driver gene in cancer that is mutated, so something like the TP53, which is called the guardian angel gene, and then what you do is you target a lateral gene, so a different gene that has become more vulnerable because of the mutation that the cancer has. So in the case that a driver gene is mutated, the drug affects the lateral target gene, and then the cancer dies. However, in normal tissue where the driver gene is not mutated, that same drug does not have that lethality effect. So this is a very good class of cancer therapeutics, but it has historically been very hard to find because you need large data sets to be able to find these kind of pair relationships. The other concept that we're doing is we are taking conventional dose response data, the drug screening data, and we're collapsing it into a single value score called S prime, and that's just a convenient way to summarize overall drug response. So we are now on the synthetic lethal scan tab, and what you have here are a bunch of large data sets, and each data set has one or more tissue lines, cancer types that you're able to look at, and then you're able to specify any kind of gene that you want, basically this is the driver gene in the synthetic lethal pair, and when you run the scan, what you get are highlighted in red are results that are thought to be synthetically lethal. They're demonstrating synthetic lethal effects, and so these are results that you can just kind of flag and export as a file for continued investigation. We now look at the cross-lens disagreement tab, and this is annotating a large number of compounds that often have no known mechanism of action. And what we're able to do is use a kind of a structural similarity to find mechanism of actions that are similar. So for example, if we do doxorubicin, common chemotherapy, we're getting some reports on what the nearest structural neighbors are and what their kind of related compounds are. Going over to the mechanism of action, this is showing in two large data sets what relationships between mechanisms of action might exist. So this is kind of giving us some ideas on related pathway information. And then what we want to call out is that this is a lot of data sets that we're very happy to be using and that you're able to do our synthetic lethality screen very large, and we should consider this a really good foundation for a pilot investigation. Thank you so much.